Domain and range. The domain of a function is the set of all values that the independent variable x can take. For the function f of x equals x plus 10, x can take all values from negative infinity to positive infinity. We see that for a linear function, the domain is pretty easy to determine. Let us find the domain of a parabolic function. Let us consider the general form of a parabola. Here, a, p, and q are constants that may take any real values. Consider a parabola with positive values of a, p, and q. The domain of a function is the set of all possible x values. Here, x can take all real number values, so the domain of the parabola is the set of real numbers. The domain would be the same even if any one, two, or all three of a, q, or p are negative. The function is defined for all real values of x, so the domain of this parabola is also the set of all real numbers. Domain of the function can be written as: the range of a function is the set of all values that the dependent variable y can take. Let us determine the range of the parabola using the graphical approach. Consider the same parabola with positive values of a, p, and q. We can see that the smallest possible value of y is at the turning point p. The parabola does not go below this point. Hence, y takes all the values between q and positive infinity. Thus, the range of the function can be given as the closed interval open interval q, positive infinity. What will the range be if any one, two, or all three of a, p, and q are negative? Consider another parabola with negative value of a and positive values of p and q. If a less than 0, the range of the function is the open interval closed interval negative infinity q. It can also be written in set notation as: the two rules would apply when q is also negative. Algebraic approach to determine the range. In the given equation, y equals a times x plus p the whole square plus q. The term x plus p the whole square is never negative, so the range of the equation will depend on the sign of a and the sign and magnitude of q. Let us build the range for the equation starting from the basic function. Here, y greater than or equal to 0, since the square of any real number is never negative. If a greater than 0, then a times x plus p the whole square greater than or equal to 0. And if a less than 0, then a times x plus p the whole square less than or equal to 0. Now let us analyze the effect of q on the range when a greater than 0. Adding q to both the sides of the equation 1, we can state that the range of the function is the set of real numbers greater than or equal to q, written as: similarly, when a less than 0, we can determine the range by adding q to both the sides of the equation 2. Range in this case is: we can summarize the results for the domain and range of the parabolic function.
Need more help? Subscribe to our channel. Can't wait that long? Ask Masky to help you and let the math finally start mathing.